Good everyone, my name is Graphics. Today we'll be looking at a topic in strength of material which is called shear force and bending moment. Now let's consider a beam. A beam that has two reactions. The reaction are at point A and point B. So the reaction at point A, we'll call it RAY, and the reaction at point B, we'll call it RBY. Now let's assume a weight or a load is acting at the center of the beam. Let me say from here to the center is the length over 2, and from here to the other center is another length over 2. So at this part we'll be having this. So the entire length given to be L, right? Now if there's a place a load on a beam, the beam is meant to resist load writing at right angle to its longitudinal axis. Now if you place a weight on this beam, if the load is too much more than it can bear and it end up breaking the beam, you call such a force the breaking force, or you call it the shear force. So that force that breaks the beam is called the breaking force, is called what? The shear force, right? So at this junction here, let's draw our center line here. Let's say we have this beam that has been broken into two equal halves. At the right hand side we have the ROBY and the load W on this part, and on the left hand side we have the load here. Let's put it at this point W, then this point here we have RAY, right? Now the beam has been broken into two different halves. So we say the shear force, which we can call the breaking force, is the algebraic sum. This is the algebraic sum of all the forces acting either to the left hand side or to the right hand side of the section of the beam, right? Now if we move further, there are some points you need to note when calculating the shear force of a beam. Point 1, point A is this. If I have a beam this way and I section the beam, so sectioning means now I have the right hand side, and I have the left hand side. Now I assume I have a reaction facing up at the right hand side and a reaction facing down at the left hand side. So when you have a force facing up at the right hand side or a force facing down at the left hand side, we say the shear force is what? Is negative. The shear force is what? Negative. That is point A. Point B, if I still have similar beam that is sectioned, so we have also the right hand side and also the left hand side. If I have a force facing down at the right hand side and a force facing up at the left hand side, we say that if the force is facing down at the right hand side or the force is facing up at the left hand side, we say that the shear force is what? Is positive. I'll give you an illustration to explain this concept. Now let's consider a beam. Illustration. Let's consider a beam, right? Let's consider a beam. Now, let's take this example and see. Now, when you're given a question on a beam, the first thing you need to calculate is the reaction to check if the beam is in equilibrium. Now, the first thing we do, we are calculating for the reaction. So, calculating for reaction. Now, the first way to calculate for the reaction is to use the condition for equilibrium. And the first condition for equilibrium is that what? The summation of all the horizontal component, that is f of x, is equals to what? 0. Now, we'll consider the forces to the right to be positive, and we'll consider the forces to the left to be what? Negative. But in this case here now, there is no horizontal component, there's no forces along the x-axis. So go to the next one. That is the summation of y, f of y, is equals to what? 0. So it means that what? Addition of all vertical components. So we are now going to consider, upward force to be positive, then downward force to be what? Negative. Now we have two upward force, which are arrow AY and what? Arrow BY, right? So the arrow AY plus arrow BY, because they are all facing up, right? All this here you see are the distances between each force. Now, minus, because these forces here are facing down, so it will be minus 2, minus 4, minus 2 equals to what? 0. So, now, my arrow AY plus arrow BY, minus 2 minus 4 minus 2 give me minus 8. Now when I take it to the other side, become a positive 8. So it's equals to what? 8 kilonewton. I'll call it equation what? Equation 1. Right? Now the next thing I'm going to do is to calculate for moment about a point. So the third condition is summation of all the moments about, let's say, point A. We can use for any of the points here, equals to what? 0. Now we are going to consider clockwise moment to be positive and anti-clockwise moment to be what? Negative. So now let's see, I'm taking moment about point A. It means that everything involving my point A is now 0. So all the forces will be going towards what? Point A. So the first one is 2 kilonewton and is going towards this direction, and that is what? Clockwise, right? So and it's positive, so it will be 2 times 1, because moment is the force times the perpendicular distance, right? So we'll be having 2 multiplied by 1 plus the next one is coming this direction also, also positive because it's going clockwise, so it will be 4 times the distance between 4 and where I take moment from. So what is distance? 1 plus 1, that is 2. So say 4 times 2. So we have the 4 times 2. So plus this one also is coming this direction. It's coming this direction like this. So we're having positive also. So 1, 2, 3 is the distance from the point I took moment to the point at which the force is. So that will give me 2 times 3. We have 2 times what? 3 plus into bracket. This is going towards this direction, going towards the points of the moment, and the distance from here to here is 4 meters. So it will be minus RBY because it is what? Anti-clockwise. And we say any force going anti-clockwise is negative. So that even times what? 4 equals to what? 0. So from here, we will 2 times 1 is 2 plus 4 times 2 is 8 plus 2 times 3 is 6 minus 4 RBY equals to 0. So 2 plus 8, 10 plus 6, that will be what? 16. 16 minus 4 RBY equals to 0. So if I take the 4 to the other side, if I take the 4 minus 4 RBY to the other side, I'm going to be having 16 equals to what? 4 RBY. Right? So if you divide both sides by 4, we are going to be having, divide both sides by 4. So this is what we'll be having. So 4 equals 4. So 4 in 16 will give me 4. So my RBY is equal to what? 4 kilonewton. That is my RBY. Now, if you look here, we have from equation 1, we have RAY plus RBY is equal to what? 8. So if I put in my RBY here, I'll be able to have my RAY. So I'm going to write substitute RBY in equation 1 above. So we have RAY plus RBY equals to what? 8. So when I substitute my value here, my RAY plus 4 is equals to 8. So RAY will give me 8 minus 4. So the RAY will give me 4 kilonewton. So we've gotten RAY and what? RBY. So let's see how it look in the diagram. Now, if you look at this very well, this is what we're having to be our diagram. We successfully got our RBY to be equals to what? 4 kilonewton, and our RAY to be equals to what? 4 kilonewton. Right? Now, the next thing we want to do is calculate for what? Our shear force, because we have successfully calculated for our reaction. Now, if you want to look at it, all the upward force here is what? Is 8. 4 plus 4 is 8. All the downward force is also 8. So the system here is in what? Is in equilibrium. So calculating for shear force that we want to look at now. Now, if you look at this, the first thing you have to do, we need to look at shear force at point B. So shear force at point B means that what? We are going to section point B. Right? So sectioning point B, we have the left hand side, right? The right hand side here, which is this side, and we have all this side from here to this side to be what? Our left hand side. Are we good? So if you look at now, it's now giving us this. It is in this form here. Our right hand side, so when the force is facing up at the right hand side, it is what? Negative. So since this is facing up at the right hand side, our shear force at B is what? -4. Right? So we say that shear force, shear force at point B is equals to what? -4 kilonewton. So we are calculating for shear force. Calculating for shear force. So now, similarly, we can also get the same thing here. We say the shear force at the right hand side facing up, we're having -4, right? So, and the definition for shear force is that the algebraic sum of all forces acting either to the left and either to the right of the section. So to the right of the section we're having -4, and let's see to the left of the section if we have -4. You don't have to do both of them, you just choose one part. But to prove some things right to you here, let's see. When the force at the left is facing down, we say what? Shear force is what? When the force at the left, this is at the left side, when it's facing down, shear force is still negative, right? So let's see. And this is facing down. After the section, everything here is what? Left. So -2, right? -4, -2, because they are the left and they are facing down. But when it's facing up at the left hand side, what happened? When it's facing up, when it is facing up at the left hand side, shear force is what? Positive. And this is facing up at the left hand side, because all these forces here are in the left hand side. It's only arrow BY that's at the right hand side, so it's facing up, so it's positive. So I put plus what? 4, because arrow AY is 4. So when you do that, -2 -4 is -6, -6 -2 is -8, -8 plus 4 will give you -4. So you see we're having the same answer. So any one of your choice, either you focus on the left hand side or focus on the right hand side, you have the same value. So let's see for the next point also. Shear force at what? At B. So you just section very close to E, sorry. So at E, let's see what is happening. You focus on the last force. The last force you have, we're looking for shear force at E. Shear force at point E. So the last force we have there was what? -4. So the next force that we're having there will be what? So when you section that, the next force we'll be having is that is facing down at the left hand side. What do we have there? We'll be having -4. So now the one is facing down. Since we've sectioned here now, everything at this, from this point to this point here, is what? Is our right hand side, while from this section downwards here is our left hand side, right? So we have the last force is -4, but the new introduced force is what? 2, and 2 is facing down at the right hand side. And I said when it is facing down at the right hand side, if you look at it, when it is facing down at the right hand side, this is right hand side, and that will be what? Positive. So we're having -4 plus this 2, right? So we have -4 plus 2. So we'll be having a value to be what? -2 kilonewton, right? So that's what we're having. Now the next one is we are going to section at D also, right? The new introduced plus force is 4 at B. So since I've sectioned close to D, so we're looking for shear force at D. So the shear force at D, shear force at D at point D is equals to, what's our last force that we have as our answer? -2. So if you look here, what is the new introduced force? And that is 4. and it's facing down at the right hand side. And when any force is facing down at the right hand side, the shear force is given to be what? Positive, because it's facing down at the right hand side. So plus what? Plus the new introduced force, which is what? 4. So I'll put plus what? Plus 4. And that will give me 2 kilonewton. That will be 2 kilonewton. Now the next thing we'll do is we are going to section at C also. We'll section every point of it. So shear force at C, I want to look for now. The shear force at point C will now give us the last value we have here is what? 2. I'll write down my 2. Now the new introduced force is what? Is facing down, and it's positive when it's facing down at the right hand side, because since I section here now, this from here downward is right hand side, and from here is what? Left hand side. But the new introduced force is what? 2. So it's facing down and at the right hand side, so it's positive. So I'll be having plus 2, and that will give us what? 4 kilonewton. Now the next thing I'll do is I'm going to section in front of A, right? So now that will be shear force at A. So my shear force at point A will give me the last force I have here, which is 4. Now this force here now is facing up at the right hand side, and we see whenever a force is facing up at the right hand side, when it's facing up at the right hand side, it is what? Negative. So what I will do is it will be minus what? Minus 4, because the new introduced force is facing up at the right hand side and is what? Negative. We're having minus 4, and our final it will now be what? 0 what? Kilonewton. So the shear force that we've calculated here are this. So now is how we draw our shear force diagram. So for you to draw a shear force diagram, you come here, at every point here you draw a straight line. You draw a straight line. At point A, you draw a line this way. You draw a line. At point C, you draw another line. At point D, you do the same thing. At point E, you do the same thing. At point B, you do the same thing. And you join the span. The span is the distance between two consecutive supports. So the distance between these consecutive supports is called the span. So I'm going to draw a straight line this way from here to this point. So the top is positive. This is my 0 and 0. So 0 up is positive, 0 down is negative. So at point B, what is my shear force? At point B, my shear force is 4, minus 4, right? So it's going downward. So at point BD, my force is what? Minus 4, so 0, minus 4 is downward. So let me say somewhere around here is 4. So because it's downward, I'll not have to put my negative. I'll just put my 4 kilonewton, right? But in between B and E, there is no force in between. So I'm going to use a straight line. I'm going to use a straight line to represent that. So this will be my straight line from here to show that there's no force in between. So in between D and B, there is no force. So here is also 4 kilonewton. Now, but at point E, our force is given to be, at point E, the force is given to be what? Minus 2. So that means at point E, we're having minus 2. So we're going to move up. This is 4. We'll go backward. Minus 2 will be somewhere around here from 0, minus 2, right? So I'm going to join this to this point, and this will be the 2 kilonewton. I'll just put my 2 kilonewton here, right? 2 kilonewton, because it's downside, I have to write the negative sign here. When between E and D there is no force, so I'm going to use a straight line to connect it from E to what? To this point here, to D. So there is no force. It's also 2 kilonewton because it is constant, no force in between them. Now at point D, there is a force at point D, and that is 2 kilonewton. At point D, the force here is what? 2 kilonewton. So that means I'll go here at D here, from 0, this is the 0 line here, I'll count 2 kilonewton upward. So I'm going to join both of them together. So this is 2 kilonewton here, right? But in between D and C, there is no force. So I'm going to draw a constant line to show the force between those 2 points are constant. And from here to here is constant. So that will also be my what? 2 kilonewton, right? So at C, the force there is 4 kilonewton. So at point C, the force has increased to what? 4 kilonewton. So from 0, this point line C here, I'm going to go up with 4 kilonewton, maybe somewhere around here. So I'll join 2 to 4 kilonewton. This is a 4 kilonewton here. From between C and A, it is constant. And I'm going to draw my constant line that in between C and A is constant. So, and that is 4 kilonewton also. Now, at point A, the force there is what? It is 0. Shear force at point A is what? 0. So I'm going to go to point A and draw my force back to 0. So at this point is 0. So all these forces here are the shear force diagram. All these are the shear force diagram. Positive, then here is what? Negative. So that is our shear force diagram. So this is how we apply. This is how we apply our shear force in a beam. How the force is distributed. So we'll call it the shear force diagram, showing the diagrammatic representation of the distributed force. If you have found this video helpful, please don't forget to click on the subscribe button. Thank you for watching.